Hello, greeting to all. Welcome back to another video presentation for understanding the principle of technical drawing. Remember, the intention of this video is using freehand sketch in this video in order to use this as a tutorial for you to complete your practical exercise at home, in case you have any doubt to know where the line come from, where to play the set square, where to play the different type of tool. This is the a sketch, freehand sketch tutorial for you to go through in your weekly practical activity at home, right? We now use no tools for this video presentation because the intention is just to let you know and help you to find out where the tool should be placed at any particular time when you are completing the exercise for the particular week in technical drawing. All right. As we studied on the theory class, for the second topic that should be completed in week number 2, we are required to be familiarized with the basic construction. And within basic construction in this particular date, we're going to be looking at definition of bisector, bisector, angle, and line, definition of angle, type of angle, construct 90-degree, 45-degree, 60-degree angle, and any combination of 30 and 15-degree angle. And at the end, we're going to be looking at how to divide a line into a equal number of parts, or how to divide a line into a ratio of a given parts. That is the topic for this particular lesson that should be complete in week number 1. Let's begin. Take a look of these information in order to understand what is bisector line. Right? Any angle, a line, when the are cut in 2 equal parts, this particular line who cut the angle or cut the line in 2 equal parts is the one that we're gonna call bisector line, right? That's a bisector. If we have a, for instance, here 90-degree angle, and we divide this 90-degree angle in 2 equal parts, the line who divide the angle in 2, we call it a bisector line. This is angle here, approximately 35-degree angle. It had been bisect in 2 equal parts, right? And the line C, the ray C, you call it a bisector line. We have a straight line here, horizontal line, that had been divided in 2 equal parts by this line. We call it a bisector line, right? In order to bisect an angle or to bisect line, when we move on till the angle topic, we're going to be looking how to construct these bisector line in order to divide the angle into equal part or divide a line into equal part. That is a definition of bisect. Line or rate that is used to divide or cut a line into equal parts. Divide an angle or cut a line into equal parts. That is called a bisector line. The next topic to be addressed here is the type of angle. The type of angle. We have a right angle when the angle is from 0 to 90. Right? The angle formed between two lines is from 0 to 90. Angle is the space formed by the intersection of two rays at a particular point, or the space formed for two rays of two lines who sharing the same point. This space here, intersecting on two lines, intersecting on a point, all sharing the same point. The space formed in there, we call it angle. Depending on the size of it, we're going to classify them into right angle, acute angle, straight angle, obtuse angle, and reflect angle. When it's from 0 to 90, right, we're gonna call it a right angle. When it's from 0 and less than 90, we're gonna call it acute angle. When it's from 0 to 180, we call it a straight angle. When it's from 0 and more than 90 and less than 180, we call it an obtuse angle. When it's from 0 and more than 180, that is from this outside here, the angle formed in this area, we call it a reflect angle. You have to be careful because the angle that is formed down here is not a reflect angle. If you notice the angle that formed down here, it's the same that angle formed in it here. Meaning the angle that is formed here is an obtuse angle, because down here is 270 degree, and between 270 degree and 0 we have a 90 degree. And the angle, if we look at it that way, is more than 90, it means it's an obtuse angle. Meaning the angle, we have to take it from outside here to determine that is a reflect angle. Right? Remember, because these are no student are participating in this video presentation, it's just a tutorial for you to have an learner guide for you to use it when you are ready to practice or start it by yourself for any particular exercise or preparing for the particular test. All right, meaning the video will be very short, and that is it. Before we continue and move on from angle, I'm going to open this blank page here, and you need to understand that, for instance, that this right here, and it going across, in order to understand the angle, this is a 0 degree angle, right? This direction is 90 degree, right? This direction is 180, and down here is 270 degree, right? In order for you to determine where is the obtuse, what is the right angle, with a reflex, what is a acute answer. Angle from 0 to 90 form a straight line is a right angle. If the line is anywhere from 0 and less than this line, we're gonna call it acute angle, right? If the line is anywhere more than 90, right? Anywhere around here, more than 90 is a obtuse angle. If the line really coincides from 0 to 180, it's called a straight angle. Straight angle. When the angle is more than 180, but it's taken from 0, right? From 0 and more than 180, right? The space that form around here is the one that I call it a reflect angle. All right? Acute, obtuse, straight, reflect, and right angle. This is to have an idea what is going on, how to determine, how to classify the different type of angle, having in consideration these are scale here. All right. The next topic here is how to construct a 90-degree angle. How to construct 90-degree angle. Very simple. Just draw the horizontal line, right? Draw the horizontal line at particular measurement given. And then you determine on the line where you want to really draw your line forming 90 degrees. When you find a particular point, just mark a point over the line and then set the compass, right? Place the compass at a particular point. Imagine that the point is point P, right? This is point P. You want to place 90 degrees at this particular point. Imagine the point P, you're going to put it. What you do? Open the compass at any convenient distance, right? And put the needle of the compass in this point and the pencil and let the compass to scribe these arcs. Make sure the arc intersect 2 times the horizontal line, right here and right here, right? When the arc intersect these 2 points, what we do, just open the compass, or you can keep the same compass open and standing here, and you mark this arc, move the compass to C, and mark this other arc. And then you draw the line, right? Draw the line from P to the 2 intersection arc, and that angle formed here would be a 90-degree angle. As a quickly demonstration, when you have the line, right? When we have the line, we want to divide this line. What we do, just say you want to draw a 90 degree at this particular point. From this particular point, what we do, we open the compass, any convenient distance. It can be done from below, it can be done from the top, right? I'm gonna do it from the top to do 2 exercises in one, right? Open the compass from the top and let the arc to move around like this, right? Put the compass in here, and needle here, and they can provide this, right? Then from this point, right, you're going to mark an arc here. And then from this other point, you're going to scribe an other arc here. Use a rule and join this point. Oh, sorry. Is that sketch? Right. I can use straight line also. Sorry. Join this point, passing through to this point, right? At the angle now formed in here is a 90-degree angle, right? 90-degree angle. Now, if we want to get a 45-degree, what we do is just bisect, right? Bisect 90 and get a 45. I mean, from this point, that's why I intentionally put the arc on the top. It's a little longer here because our sketch, when you do it with tools, will be perfect size of the arc. Meaning from this point, we're going to mark the arc here. On this other point, we're going to mark another arc in here. All right, mark another arc in here. Then you get a line, right? And from this point, you draw a line passing through to the center. And now we're going to have a 45-degree here and 45-degree on this other side. That is when we want to draw or construct a 90-degree and 45-degree angle. The second exercise is how to construct 45-degree. And now let's look at how to construct a 60-degree angle in technical drawing. Right, 60-degree angle. When you have the line BC at the given size, BC, say for instance, BC is 70 millimeter. Using the T-square, you draw on a horizontal line, and then you measure it 60 millimeter. Then you open the compass at any convenient distance. There's no exactly size. And stand the compass in B and create an arc in this way, forming the arc. Create this arc like this. When you have the arc like this, without changing the size of the compass that is open, the size that you open the compass to create the first arc, without changing that size, you stand in D and cut here the first arc that you create. When you cut this first arc, then you draw the line from B, passing through to the intersection, and that angle, that space formed by the two lines that is sharing the same point B, going to be a 60-degree angle. Let me pull the board here to make a sketch in order to understand a little better this. This is the line, right? Want to get a 60-degree angle, you just open the compass any distance from this point, any distance, and you make it to bisect this. Open the compass any distance and let the compass to create this arc. Then from this point, without changing the size of the compass, create this arc, you let the compass to cut again around here. From here, the compass will intersect the arc right here. Then you draw with a rule, draw a line passing through to this point, right? Passing through to this point, and the angle that is formed inside here will be a 60-degree angle. That's the angle that formed in here will be a 60-degree using that particular technique. If we have a 60-degree, and we want to get a 30 and 45-degree, we use the same technique that we bisect 90 to get 45. Same technique. Meaning from this point here, we create an arc here, and from this other point here, that's 60, we create an other arc here, right? Then use a line command, use a line to intersect, to make sure pass through to the intersection point, And now we have a 30 degree right here. We have a 30 degree in here. And we have a 30 in, yes, in this other section here. That's how divide a line in two equal parts, 30. Divide a 60 degree angle in 30 and 30, two equal parts. Remember, at the beginning of class, this line is called a bisector line, right? Because R dividing an arc angle in two equal parts. The line that I use to divide angle in two equal parts, or the line that I use to cut or divide a line in two equal parts is called a bisector line. The last exercise related to angle is how to construct a 15-degree angle. For a 15-degree angle, we going to bisect right here the 30 degree from this point, from this intersection point. We're gonna intersect, we're gonna create an arc here. From here, you open the compass and you create our here. When you're done, you draw a line from this point, make the line to pass through to this, and that line will be 30 or 15 degree and 15. You divide 30, now you get a 15 degree and get a 15 degree in that size here. Right, 15 and 15. That is the way that we're going to create on a 60 degree, 30 degree, 15 degree angle. The other exercise is when we have on 90 degree angle, right? When we have a 90, and right, say you have the 90 degree line. I want to divide it in three equal space. You want to divide it in 30, 30, 30. In order to divide it in 30, 30, we have to use a compass and let the compass stand at the intersection of the two lines forming 90 degree, and then you create an arc. Create an arc that way. You create an arc like this. Right? The technique that we use for 60 degree angle is the same technique. We're gonna use it twice to create a 30 and 30. We say that 60, we need to, from here, we need to bisect here to create 60, same thing we do here. From here, the same size, you create this arc, you stand the compass in here, and you cut on this side here. And then you move the compass to this other side here, this other side here, and let the compass to cut that one here. When you get that one, you're gonna have this line passing through here. Sorry, this line, we draw a line passing through here. That will be first 30, all right? First 30, and the second one is passing through this one. It's a second 30. We have here now 30 degree. We are now here 30 degree, and we have here now 30 degree, right? 30 degree. Remember, everything I'm doing is a freehand sketch because the intention of this video is just to explain how to do the exercise. It's not for me to do the exercise with tools and so on. It's a guide, learn a guide for you to follow the instruction and be able with your tool to complete your drawing. Right? It's just a freehand sketch in order to do the video quickly for you to understand and has the full information how to complete a particular task. Right? Let's look at in the instruction here, the objective for the class. The next topic for us is to, how to divide a line in two equal parts, right? Right, yes. How to divide a line in two equal parts, right? For this particular case, we're going to draw the line AB, right? Draw the line AB, right? And then you open the compass, stand in the middle of the compass in A, and open the compass somewhere greater than the half of the line, never less than the half of the line. You don't know exactly where is the half of the line, but approximately you will know that anywhere that you open the compass around here will be greater than the half of the full size of the line, right? When the compass is greater, open greater than the full size of the half of the line, you're gonna standing in A, you're going to bisect here, you're going to mark the arc here, and then you're gonna mark arc here. Then you switch your compass from A to B with the same size is open, and you intersect the first arc and intersect the second arc. Then use a straight line and with ruler and connect the two intersection arc, connect them, and the line, the horizontal line, will be divided in two equal parts. Right? Let's try this. Say we have a straight line, right? And we want to divide this line in two equal parts. Right? From this point, right? We open the compass somewhere around here, greater than the half of the line, and then we create these arc here. And then move the compass down, and we create the next arc here, right? Then you switch the compass from this end to the other end with the same side as the compass is open. You go back here and you intersect this point, and then you're coming down and intersect this other one. Right? When you're done, just with a rule, join this point to this other point, right? And you're going to have the line for the size A, the size A here will be equal to the size B here, equal in size to the side B. The line going to be divided in two equal parts. For next exercise, divide the line into an equal number of parts. Divide the line into an equal number of parts. In this particular case, we have the line supposed to be this line, right? 100, they're giving the length of the line 101 millimeter, and they want it to be divided in a 10 equal parts, right? 10 equal division. Let me explain here on the drawing, and then we go. Let me zoom a little for better seeing. All right. For this particular case, when we draw the line, the horizontal line AB, at 101 millimeter, if this is the measurement given to us, the first thing we have to do is to create an acute angle between the horizontal line and this line, forming acute angle. Never can be a right angle and never can be greater than 90. Never can be obtuse, right? Have to be acute, and the size doesn't matter. The size of the acute angle formed down here, no matter. The important is to be acute angle, less than 90. We open the compass then, smaller distance, about 6, 7, 8, 9, 10 millimeter. The size doesn't matter, in order to stand at the point A and mark here the acute line. Stand from 1, you mark point 2. Standing 2, 3, standing 3, 4, and so on. You create the 10 mark. Always join the last intersection here, connected to the end of the line. Always, that's a rule. Connect them to the intersection of the line. When it's connect to the intersection, the last point to the end of the line, sorry, connected to the end of the line or the horizontal line, we need to use 2 set square, right? We need to use 2 set square in order to draw from 9, get this line. All of these lines have to be one parallel respect to the other one. One have to be parallel line respect to the other one, using 2 types of set square. In order to understand the use of 2 set square, let me sketch the position of the set square here in order to get a little better understanding of it. I say for instance that we have these horizontal line, right? And we want to divide this line in 4 equal parts. Right? We want to divide this line in 4 equal parts. The first thing that we have to do is create an acute angle here. Create an acute angle here, forming from the horizontal line. Then you open a compass any convenient distance, and starting from this point, you let the compass mark here. From this point, you mark here. From this point, you mark again here. From this other point, you mark again here. If the division of line is 4 equal parts, we have to mark 4 times here. If it's 6, we mark 6. If it's 10, you put a 10 division here, right? In this case, to make the exercise shorter, I just using 4 division in here, right? We call it number 1, number 2, number 3, number 4, right? If it's 5, 5, 6, 6, 7, 7, right? The key is that the last mark that we have here, always we have to connect it to the end of the line, right? The last one, we have to connect it to the end of the line. Then we need to use a set square. Let me put it in blue color and thicker line, right? We use a set square, and we put a set square in line with this line. Look at these. Say this is one of the set square. All right. Put it too big. We put it like this. Say this is one of your set square. Let me erase this. right? This is 1 of the S squared. This is 30, 60, 90. And then the other S squared, we're going to place it, the other S squared, we're gonna place it to be in touch with our, right? The 90 S squared, we're gonna place it in here, this way here, right? Put on the 60, 30, 90 right here, and put on the 45, 90 this side here, right? What will be happening then now? You're gonna place your hand in here, holding this one. Put on the left hand to hold this square, and then with the right hand, you're going to push or slide these in this direction. You're gonna slide in this direction. What will be happening when it's lined up with the end of this line here? When you slide it, these edges of the set square, when it's in touch with number 3, when it's in touch with number 3, you will be able, right? You will be able to draw the line. You will be able to draw the first line. When you draw this one, slide again the set square, slide it until in contact, until line up with number 2, and then you draw your second line. All right? Then slide it some more until reach to point 1, and then you draw the last line. When you've done this, you will see that you will have a point 1, point 2, point 3, and this one will be point 4. This line will be divided in a 4 equal division. This is the same principle if we're going to divide them in 10 equal parts. Only thing change, if we want to do 10, we need to create here 10 division equal part here. If it's 8, 8, if it's 6, 6, 7, 7. All right, that is the idea how to get through to the technique of dividing line into an equal number of parts. The last exercise for the lesson is similar to this, but it's calling divide line in a ratio, right? Divide line in ratio of part, right? How to divide line ratio of part. Say for instance that, let me show you first an example and then come back to the sketch. This particular case is asking to divide line in ratio of 3:2. Divide line in ratio of 3:2. When you have the given ratio, the first thing you need to do is add the R value on the ratio given. This we have a 3 and 2. We say 3 plus 2. 3 plus 2 is equal 5. The addition result is the number of division we're going to create in this diagonal line. If the addition here says 9, we create a 9 division. If it says 6, you create 6, and so on. For this particular one, say ratio 3:2, we have to 3 plus 2 equal 5. We create a 5. You understand this? Just put on the line AB, sorry, line, the horizontal line, call it. Suppose the measurement is 100 millimeter, and you want to, don't put a 100 because somebody might say 20, 20, 20 of, right, 25, 25, 25. No, put it at 103 millimeter, and you want to divide it in 4 equal parts. You can divide with a ruler 103, because it's hard to find the equal space. Using this technique, 103 millimeter horizontal line, create this diagonal line forming an acute angle, and then divide it in 5 equal space. Join the line, the last line, the last mark, join them to the end of the line, and then using the combination of the two set square just given a while ago, you're going to draw the ratio value from back to front. The last value is 2. You slide the set square, counting 2 division, 1 and 2, and you draw this line 2. Then you slide the set square, counting 3 division, 1, 2, 3. Because there is no other ratio value in front to 3, you don't need to draw no line. Meaning, and in this particular case, on the top of the exercise, you write here 3, and here you write 2, indicating that here we have a 3 equal space, and here we have a 2 equal space. And that is how we create a ratio. We create a ratio of given value. In this particular case, 3, 2. Let's look at in the demonstration sheet to understand this properly. The one given in there was 3, 2. Meaning you said 3 plus 2. The ratio was 3, 2. What you do, you say 3 plus 2 is equal 5. Any ratio you get, just add the corresponding value. The answer you get, this is the amount of, say the line is a 103 millimeter, right? 103. First thing you have to do is just create an acute angle in there, and the answer is 5. You need to, from here, you need to say 1, 2, 3, 4, 5. Always take it from the previous mark, right? And call it 1, 2, 3, 4, and 5. Right? And 5 this. Usually, always connect the last one to the end of the exercise. Right? Always do that. Connect, always, sorry. Always just connect the last one to the end of the exercise. And using this combination to avoid draw it again, the 2 set square, put a 1 set square to line up with these black line, right? And put the other set square to line up this. But what will be happening now, because it's a ratio, we only need to draw the line that representing the ratio. The line representing the ratio is from the back to the front. We say we slide the set square and we count it 1 and, sorry, we count 1, count 2, and this is the line that we draw. Right? This is the line that we draw. We now, because it's only 2 values here, we don't need to draw all the line here saying 3. No, we don't have to do this. Right? Just leave it like that and you count it. 1, 2, 3. This is number 3 here. You say 1 and 2, and this is number 2. Right? This line has been divided in ratio of 3, 2. Right? Quickly, if the ratio is greater than that, for instance, you have a ratio, let's say 3, say 1, say 2, and say 4. Let me give you a bigger one. Say divide a line in ratio 3, 1, 2, 4. In this particular case, what we do, we add the value. I will say 3 plus 1, 4, plus 2, that's 6. Plus 2, that's 6. Plus 4, that equals 10. And we say that the answer for this is 10. Adding all of them. When you get the length of the line, say the line is 77 millimeter, the line is 77 millimeter, you draw your horizontal line at 77 millimeter, and you create your acute angle from this corner, create your acute angle. How many, what was the answer here? 10. We need to cut this 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let me put 10 right here because can't move the screen no more. Screen can go up no more. All right. Just connect the last line. And then connect it to the end right here and follow the same technique of the 2 set square. You're going to always put on a number here. Don't forget to put a number here. 1, 2, 3, 4, 5, 6, 7, 8, right, 9, and then just somewhere around here, put a 10. Can't fit in there, and that's no problem. It's just a guideline to understand the principle, how to get through to the drawing. All right, put in the 2 set square, as I explained earlier here, right? We're going to start from back to the front, right? What is the last value on the ratio? 4. We're going to slide the set square, leaving 4 division, or counting 4 division. Say 1, 2, 3, 4. And we draw this line. We draw this line, right? The next ratio is 2. We say 1 and 2. Slide the set square until line up with this. And we draw the other line. The next is 1. We slide the compass, sorry, the set square, 1 more space, and we draw this line. And the last one is 3, because this is the last one. We don't need to draw a line here. You just say 1, 2, 3. When you're done, just place the value of the ratio on the top of the horizontal line at the indicating point. We set here 3 space because we have 1, 2, 3. 1 space because we have 1, 2, 1, 2. We place 2 here. And then 4, we say 1, 2, 3, 4. This is 4. That is a line. That's a line divider in ratio, right, of 3, 1, 2, 4. All right, this is the end This lesson 2 corresponding to the week number 1. Now with this tutorial, you should be able to get your paper and your tools and practice these exercises I had been explaining in this tutorial. All right, I hope this has been useful for you. And when you come to the practical class next week, you're going to be demonstrating what you have been learning and what you have been practicing from this tutorial. All right, have a good day. All the best. See you in the next practical class. Remember to give a like to the video and subscribe to the channel to get another information when any other video been loaded to the page. All right, bye bye. See you in the next presentation.